So I'm Tom, and I will be presenting our work, well, the work that me and my colleague Victor over there were doing. So it's on well, security analysis of mobile-first sites. So mobile-first sites are sites that are specifically developed for mobile users. So for instance, if you go to twitter.com, you might, and well, with your mobile device, you will end up on mobile.twitter.com, which is, well, actually a different site than the, well, regular twitter.com that you would see when you would visit the site with your desktop browser. So usually they're hosted on a different subdomain. So usually m.example.com, like m.facebook.com, m.whatever. And so, well, it's like already a fun anecdote that we discovered during our research is when we were looking into things, we found that this mobile version of these sites were already being used as kind of phishing attempts. So instead of the dot, they would put a hyphen, and then it would look to users that they would be on twitter.com, amazon.com, and so on. So for instance, yeah, m-amazon.com is hosting some kind of scam and malware stuff. So if by accident you would type it incorrectly or something, then you would end up on a site like this. So yeah, it would, well, try to get you to accept the notifications, and when you reject it, you're forwarded to another site. And so here the redirects happen very fast because I blocked them already. But yeah, usually well, and you can see that eventually you end up on some malicious sites, and most likely the previous sites were also malicious, but they weren't caught by the firewall over here. So I did this recording today. That's why you see the RAI there. But anyway, these mobile-first sites, they're typically developed several years after the desktop version. So we try to get like an estimate of how much time is in between the development of the both sites. And we found that in a median, a mobile version of a site is developed around 6.8 years, so almost 7 years after the desktop site. And we used these mementos to find the first occurrence of the desktop or the mobile site. And this allows us to, well, this kind of creates a unique viewpoint on how security is applied, because we have two assets of the same company or same organization that, or like web assets that are developed, one like typically 7 years before the other. So that's kind of creates a unique viewpoint. So if we make the assumption that if a website is developed several years later and security is applied at design time, then these websites that are created later, so the mobile version of the site, they should contain newer security features than these other sites. So when we talk about web security, we can kind of summarize it as two things. So yeah, you have either the good, well, the vulnerabilities, and also the security features that try to mitigate them. So either they will completely mitigate it. So for instance, if you set, or if you correctly set the X-frame options header, then well, you will be safeguarded from click checking attacks. Or it will try to counter the, or limit the consequences. So if you set the HTTP only attribute on a cookie, then this cookie cannot be stolen through cross-site scripting attacks. So what we wanted to figure out in our study is whether these security mechanisms, whether they're applied well, ad hoc, so after an application has been developed, or during the design time. And yeah, how are they applied? So is it like only will a website only configure a security feature for certain aspects, or will it do it across all its endpoints? So in order to figure this out, we did four-legged, well, our research consisted of 4 different parts. So first, we wanted to find these mobile-first sites. In the second step, we then try to obtain the different kind of features. I'll go into more into detail later what these features are and how they try to capture the security hygiene of a website. The third part of our study was a more statistical analysis where we compared the security of mobile sites versus their desktop counterpart and vice versa. And then in a later stage, we also looked into more detail into certain security features on how they are adopted. So the first part of our study was to find mobile-first sites. And in order to do so, we visited websites with 2 browsers. So we have our own crawling infrastructure, which is based on headless Chrome or headless Chromium. And in the one part, it was the basic one. And in the other one, we made the browser appear as if it was a mobile browser. So we changed the user agent string, we emulated different screen dimensions, and so on. And so we visited 1 million websites, and we captured the redirects that were occurring for these both browsers. So if the redirect happened, if the user was redirected to a different domain or a different subdomain on the mobile client than on the desktop client, we considered this as a potential mobile site. So we used the top 1 million Tranco sites, which is a research-oriented list for most popular websites. And we found that a bit over 15,000 websites of these 1 million sites redirected users to a different domain or subdomain when they were visiting over mobile versus when they were visiting over desktop. But to kind of clean up our data, we had to filter the websites that were kind of irrelevant. So some of them redirected users directly to the Google Play Store to kind of trigger them to install the application rather than just serving the mobile version of their website. Some of them where the website was not accessible, some of them were empty. Then there were also some duplicates. So like google.com and google.nl, we only considered one Google there. We tried to find these by using a perceptual hash, and then we clustered all the different groups, and that's how we managed to figure out the duplicate sites. In the end, there were also 512 sites that we found that were compromised. And I'll go into more detail in the next slide. But so in total, we found 10,222 sites that had a desktop version and a mobile version that was served on a different domain or a different subdomain than the desktop version. And these are all unique sites. But so, another anecdote is that we found during this filtering process 512 compromised sites, and I manually looked into it, and I actually managed to obtain the source code of one of these compromised sites. So what happened was, if I, with my mobile browser, would visit one of these sites, I would get redirected to this www.type.ru, which is like a kind of suspicious site, and this site would redirect me to some porn sites with some affiliate number, such that they might get some revenue out of this. But by observing the source code that I obtained from one of these sites, I figured that it was most likely that this compromise was related to vulnerability in some WordPress plugin. And well, after exploiting this vulnerability, the attacker uploaded an htaccess file to the root of this domain. And then when this htaccess would check for the mobile string in the user agent string, and if this was present, it would redirect the user. So this type of malware, I think, it tries to like hide from the administrators, because an administrator might be more likely to figure out that something bad is happening on their site when they are when they visit it over their desktop site, but it might be less likely that mobile users that the administrator would figure it out when it's only mobile users who are being redirected. Okay, so that brings us to the second part of our study, obtaining the different features that capture the security hygiene. So the security of a website can be considered as like the vulnerabilities that it contains and the defense mechanisms that are used to prevent them, or to harden the website against them. So what we could do is we could try to find vulnerabilities at a very large scale to figure out all the different vulnerabilities. But this is very difficult, especially from an academic perspective, because, already by just crawling sites, we get certain complaints of companies that think that we are somehow abusing them. And then if we would run actual attacks against sites, well, that also wouldn't be very ethical. And also, if there was this universal technique to detect vulnerabilities, everyone would be doing this, and OWASP probably wouldn't need to exist, because all vulnerabilities could be detected and fixed. So it's often very site-specific, so it's very difficult to find all these different vulnerabilities. So that's why we went a different way. So we tried to focus more on the defense mechanisms that were used. So the usage of these mechanisms is typically recommended by browser vendors and other organizations such as OWASP. And it makes it also much easier for us as researchers to observe the usage and adoption of them, because these mechanisms need to be communicated to the browser, and that allows us to just capture these typically through like a response header. And yeah, it allows us to capture all the different features that are being used. So I won't go into detail on all the features, but I just want to show that we covered like different classes of security mechanisms that counter different types of vulnerabilities. So the HTTP only attribute and the content security policy, which are like either an attribute on the cookie or in the case of content security policy, a new response header. We also did look through the DOM to find forms that contained a CSRF token to prevent CSRF type of attacks. Of course, in our study, we didn't log into or register and log into sites. So these CSRF tokens would only defend against login CSRF attacks. And then the click checking defenses. Some other things like MIME sniffing attacks that can be defended against by the X-content type option header. Quite some features that we're trying to tackle the man-in-the-middle attacks. So we already considered using HTTPS as a good security practice. And well, that's important to remember if you look at the numbers later on. And then, yeah, some others like the secure attribute on cookie, the strict transport security headers, and so on. And then also some things that can possibly go wrong, like mixed content inclusion. So when we are on an HTTPS page and we include a resource that's loaded over HTTP, that's mixed content. Then SSL stripping, where well, that's like a vulnerability where the page is loaded over HTTP, but then there's a form that links to HTTPS. But as an attacker, we can modify this resource over HTTP and strip out the S such that the form will still be submitted over HTTP. And yeah, then finally, yeah, also some other things like the sandbox attribute on iframes, which can be used to determine what an iframe is allowed to do. And then there's, well, sub-resource integrity, which is the integrity attribute. And here we mainly looked for this attribute on scripts. And then finally, the refer policy, which kind of gives control to the web developer on which referrer headers will be sent to third parties. So an important note that I should make is that, well, if you're developing an application, you don't necessarily need to implement all of these different features. It often depends on well, the type of the characteristics of your application and the specific functionality that you offer. So, for instance, if you don't have any forms or any actions that can do harm, then defending against a C-server attack, there wouldn't be something that you would have to do, or you could allow web pages to frame you if that's part of the functionality that you provide. So then you wouldn't have this X-frame options header. But in general, we wanted to capture the security consciousness of the web developers, and mainly the difference between the adoption of security features between the mobile and the desktop version. So we want to see if web developers actually considered using one of these features. So in total, we checked for 11 defense mechanisms and 4 potential weaknesses. So these are not actual vulnerabilities, but in some cases they might be, so we consider them potential weaknesses. And then we actually obtained the data by visiting up to 20 pages per site, and that's both on a desktop browser and a mobile browser, so the emulated mobile browser. And yeah, we used our customized crawler infrastructure that we built at our research group. And then after we obtained all the data, we could actually start performing some statistical analysis. Like the first thing that we looked at was the number of features that websites would deploy. So, the most interesting thing to look at on this graph is the bars at the point 0. So there you can already see that there are fewer desktop sites that do not have any of these security features compared to the mobile sites. And then when we move more towards the right, so websites with more security features implemented, we can see that the desktop typically has a lot more, or not a lot more, but consistently more security features implemented than the mobile counterpart. But this is like a very rudimentary thing. So we wanted to figure out whether mobile sites are actually more or less secure than their desktop counterpart, and also which security features are more or less prevalent on mobile sites, also compared to their desktop version. And finally, we want to know whether these the efforts that are being made to adopt these features are because of the web developer that made them, or because of some other influences. So we used the Wilcoxon signed rank test, which is a statistical test for paired samples, and that's good for us because we have these paired samples. So we have the mobile version and the desktop version, and it also does not rely on a priori assumption of the data distribution, which is also good because we don't have this. So we used this test, and then we also performed a mediation analysis because more complex websites might have more features just because it's more complex. So we wanted to consider what the effect of this complexity is, although complexity is a rather vague term. So in our analysis, we considered complexity as something feature specific. So for instance, for the HTTP-only attribute on cookies, we considered complexity as something in terms of the number of cookies that are being set on the site. And well, then we did all this statistical analysis, and we got this very nice big table. So I won't even try to tell you where to look at, but what we can summarize this table as is that we found that security features are more prevalent on desktop sites, which we already saw in our bar chart before, and especially for features related to man-in-the-middle defenses, the effect of the device, so the fact that that it's a desktop site has the biggest effect. So for most features, however, the effect of whether it's the mobile version of or the desktop version is very limited and often statistically insignificant. So this kind of shows that there is a somewhat consistent application of these security features across the mobile and desktop version of the site. And our mediation analysis showed that there is an impact of the complexity on the adoption of these features. So for instance, sites with more cookies, or like, for instance, we saw that desktop sites had more cookies, and therefore they were also more likely to have this HTTP only or secure attribute on one of these cookies. And then when we look at the different features separately, we can see that overall the adoption of these is very low. So you can the exception is the usage of HTTPS, which now around 60 or 70% of the sites that we considered were deploying. But then for the other features, we see that the adoption is fairly low. So yeah, almost all of them except the HTTP only attribute, like all of them were less than 20% of the sites that use it. And what you can also see on this figure is that the number of features where there's an overlap of where both the mobile as desktop version are using it is relatively high, with a few exceptions, such as the HTTP only attribute, where we see more desktop sites are using it compared to the mobile version. But this can likely be attributed to the type of framework that is being used. But that I will be talking about a bit later in this presentation. And that brings me to the fourth part of our study, so the in-depth analysis. And we looked into more depth in two specific security features, namely content security policy, because it's a very diverse and complex mechanism, and well, it has an impact on many different site features. And there was also a prior study in 2016 that focused specifically on content security policy, so that allows us to compare with this previous study. And we also looked at the adoption of HTTPS because, well, most sites have HTTPS adopted, and it's also the feature where we found the most effect of which version of the site was being shown. So for content security policy, we found 502 sites or desktop sites that were using it, and 482 sites. So that's not that much in total. So I think around 5%, a bit less. But what we saw is that when content security policy is defined, most sites enable it on all the different pages of their site. So both for the desktop, where we've found around 80% of the pages that were covered when CSP was enabled, and yeah, something similar for mobile. And we also, what was also interesting is that we found that on more than 90% of the pages, so when CSP was deployed, we found that the same policy was employed throughout the entire site. But then we looked into like the usefulness of these policies, in particular to defend against cross-site scripting attacks. And so we well, ran all of these policies through the Google's Content Security Policy Evaluator. You can just Google for this and you will find it. So you basically tell it, you give it a content security policy, and it will tell you whether there are any issues with it. And what we found is that almost all, so there's only 2 exceptions for desktop and 3 for mobile, they all had high severity issues with their policy. And most of them was related to the unsafe inline property. So then when we want to compare with a study from 2016 to kind of see how CSP is evolving, we can see that in our study, the default source, so the second line there, was only used by around 34% of the sites, whereas in the previous study, they found that 85% of the sites were using it. I should note that this study from 2016 was also by people from Google. It's based on a different data set, so that might explain to some extent why we see different things. But I think that the evolution can still be seen there. And what's also quite interesting is that these newer features, like the newer directive, such as block all mixed content and refer and frame ancestors, are being used a lot more than 3 years ago, or 3.5 years ago. So I think that's, well, a quite interesting finding. Then moving on to the analysis of the adoption of HTTPS. So we found around 62% of the sites were using HTTPS on both the mobile as well as the desktop version. And most of them, so around 70% of these 62%, had a secure implementation on both sides. However, there were 665 desktop sites that were secure where the mobile version was insecure or had some issues. And that was mainly related to the mobile version automatically redirecting to HTTP. And around, well, for around half of that, we saw the inverse, so where the mobile version was secure, whereas the desktop version was not. And that was mainly related because there was some mixed content inclusion on the desktop part. And yeah, here you can see this in graph form. So you can see the, well, the light blue line going from secure on the left side, so the desktop version, to redirect to HTTP on the right side. And also the HTTP resources, the darker blue one, from the desktop flowing to the secure one on the mobile. So we did all of these analyses, so what can we conclude from this? So we found that the adoption of security mechanisms is quite similar on the mobile as well as the desktop version. So both in terms of which security mechanisms are being used, as well as how they are being used, or how they are being implemented. And from this we can, well, if our previous assumption holds, that a newer site will have newer security mechanisms, if security is considered a design time, we can say that this hypothesis is not valid because we saw that there is a similar adoption of these security mechanisms. So it's most likely that security is is used as something reactively. When you already have a website and afterwards you decide, now I want to employ some security mechanisms. And then we also found that overall mobile sites have fewer security mechanisms, which might be because they don't really need it, or there might be less interest in securing them. And also what's kind of sad is that the adoption of security features is quite low. And then when we actually look at the attribution of these security features, so when we try to figure out whether it was because of the efforts made by the web developer that this mechanism was deployed, or by something else, we actually found that many features, such as the HTTP-only attributes on cookies, were related or were there because the website was using a framework such as WordPress, and WordPress by default sets the HTTP-only attribute on cookies. So this means that actually the adoption is even lower. So there's still some work to be done in this attribution because it's not straightforward, because the presence of a security feature can depend on many different things. It might be the web stack that adds it there, or certain third-party libraries, or other type of scripts that make the feature to be there. And this can be either direct, so in case of WordPress, or indirect through some other third parties that add it. But it is important if we want to capture the security efforts that are being made by the different websites. And so that means that the conscious security decisions that are made by the security by the web developers is even lower than this 5 to 20% that we reported in our study. And well, that's quite sad. But how do we move on from here? So what are the good things about what we found? So we found that actually sites that are using WordPress, for instance, they will almost all of them will have this HTTP only attribute. So that got me thinking, like when someone would create a new website, well, if they don't consider any of these, so when someone is creating a new website, wouldn't it be nice if you would start from already a more secure version, and then if you would need to, so for instance, a more secure version would already adopt all of these different security mechanisms, or at least a selection of them. And if you would somehow have to make an exception because these security features are blocking what you want to do or want to achieve, then you already make the web developer think about the change that they are doing and then the potential consequences of making this change. So, well, I think this would be nice to have, but it's a bit tricky because security features are constantly being added. New security features are being added, and existing features, like for instance CSP, are also being changed. So it's difficult to figure out how to start from a secure version of what a website would have to look like. But still, even if you don't consider everything, it's still significantly better than not having anything at all. So what else can we do? So we know that websites will likely have some vulnerabilities. I don't think anyone will claim that their website is 100% secure. So what we can do is we should try to make exploitation more difficult or impossible for the attacker by, for instance, employing one of these security mechanisms. Another thing that we can do, and I think that's an important takeaway of this presentation, is that we should try to reduce the threat surface that users are facing. So for instance, if you have a mobile website, then it wouldn't make any sense to expose desktop users to this mobile site, because any vulnerability in the mobile version of the site would affect or should only affect mobile users, and the same for desktop. Vulnerabilities in the desktop site should only be affecting desktop users. So it's very simple to, based on the user agent string, detect whether the current user is on a mobile device or a desktop device. So we should already make sure that desktop users cannot just be, cannot simply browse to the mobile version. So if we just have some redirect beforehand, that would already prevent these users from being exploited. So that brings me to the conclusion of this presentation. So we performed this large-scale comparative study on mobile-first sites, and this kind of provided us with a unique viewpoint, because mobile sites are typically developed years after or several years after the desktop site. We found that desktop sites have a slightly higher adoption of security features, but in general the adoption of security mechanisms is still quite low. Although we did find that when a security feature is being adopted, it's typically universally adopted across all assets of a website. And we also have some indications that the usage of these mechanisms is not considered during design time, but only applied retroactively. And yeah, so we also found that by having more complexity, websites are also more likely to have one of these features. And also it's sometimes quite difficult to attribute who made this feature to be there. So there's still some work to be done in order to correctly attribute the presence of a certain security feature to the efforts that are made by the web developers. Overall, yeah, the adoption of these mechanisms is quite low, but moving onwards, it would be nice if we can have some mechanisms where we have a secure, well, where we start from a secure point and then develop applications starting from there, rather than the other way around, by first making an application and then trying to secure it. And then, well, the last thing would be that you shouldn't, or should try to not expose users to unnecessary threats by, for instance, redirecting desktop users to the desktop site automatically. So we did a bit more of, well, there's more details to be found, and I would like to invite you to take a look at our paper, which you can find on this link. And with that, I would happily answer any of your questions.
Well, what kind of simulator did you use for mobile sites?
How do you mean simulator?
I bedoel, wat voor browser?
So we used headless Chromium, and we used the simulator that's built into Chromium. So you can also just use Chrome and then open the developer tools, and then it uses this. And then we made some custom modifications to make sure that websites would detect it as a mobile site.
Nice research. Did you try to reach those owners with the biggest issues?
Well, we didn't really look for issues. So the lack of usage of these mechanisms is not necessarily an issue. So you can have, if your website would be perfectly safe and secure and there would be no vulnerabilities, then it's not, well, strictly necessary to use one of these features. So we mainly looked at like the positive side, which turned out to not be that positive. But yeah.
Yeah, really nice research. I was wondering, since you did a lot of crawling, did you mainly look at public sites without where you are not logged in? Because I'm wondering if that could make a difference regarding if there's no session cookie, then maybe the cookies, there are less protection measures for the cookies.
Yeah, I think it would definitely be interesting to also look into well, the logged-in version of the sites. However, creating accounts for 10,000 sites and automatically logging into them, well, it might be feasible, but it's not that trivial. So we unfortunately couldn't look into that. But I do think that by doing so, we would probably find some different things.
We have time for one more. I'm sure you'll take questions afterwards.
I'll be fast. You got my attention when you were talking about the redirects. What I noticed quite a lot are the redirects to malicious sites due to malvertising. Did you get any interesting insights during your research into this thing?
How would you, or which did you mean, the like the Amazon.com type of thing, or?
For instance, even if I visit a legitimate website, like a news site or something similar, I sometimes get redirected to malicious site due to an ad, due to a malicious ad. So my question would be, did you also notice such behavior during your research? Was it a bit? Was it a lot? Not at all?
Well, in this research, we didn't encounter, as far as I know, any malicious advertisement, although we also didn't actively look for it. But we have current ongoing research that looks specifically into malvertising and kind of try to figure out the entire ecosystem.
Okay, I think that's all the time we have. The keynote, the end of the day keynote is downstairs now in 10 minutes. Thanks, Tom.